Welcome, Lagrange multipliers. To find the maximum or minimum of a function f of x, y, subject to a constraint like a budget, g of x, y equals 0, this occurs when the two gradient vectors grad f and grad g are parallel. Let's draw that. Grad f and then grad g. So I'm just drawing two parallel vectors. This occurs when they're parallel. So if they're parallel, then this is a multiple of this. Let that multiple be lambda. So that gives us the equation grad f is equal to lambda times grad g. Now let's take a familiar problem that you might have done in an earlier course about maximizing or minimizing something. A farmer has 1,200 meters of a fence and wishes to enclose a rectangular area. All right, so let's sketch this rectangular area. Say the side length of this side is x, the side length of this is y. And so the perimeter is the sum of these side lengths, all four sides. So that gives us 2x, because there's 2 of those of length x, plus 2y is 1,200 meters. Now the function being the area, so let's say f of x, y is equal to the product of x and y, the area. So we want a maximum area subject to this constraint here. All right, so this says do this with Lagrange multipliers, so this technique, but I want to also show you, remind you of the technique that you used in functions of one variable calculus. So what you would do, you just say, okay, I've got this constraint here. I need to solve this equation for y. So say using univariate calculus. So we then have y is equal to, dividing this throughout by 2, 600 minus x. And then what you would do is you would sub in that value, 600 minus x. And so we've got the product of x and 600 minus x. And now we would expand that out and get 600 minus x squared, and then use your tools of calculus differentiating that, because that is now just a function of x. And so we have minus 2x. Oh no, I'm missing in the expansion, there's an x there. Okay, so minus 2x plus 600. Okay, when is this equal to 0? Well, this is equal to 0 when x is equal to 300. And if x is equal to 300, well, the constraint here would give us that y is equal to 300 as well. Okay, so then the farmer should choose dimensions x and y, 300 and 300. Right, now with Lagrange multipliers, what we do is we let g of x and y be equal to 2x plus 2y minus 1,200. So in other words, we take everything to one side so that we have 0 on the other side of the equation. So now grad f is, just looking at this, and here incidentally is a plot of the function f together with the constraint. So the function f here is shown in orange or yellow, and the constraint 2x plus 2y equals 1,200 is this blue plane here. And so the intersection of these two is the constraint and is maximum up here at the top, right? 300, 300. All right, so in terms of gradient vectors, so the gradient vector would point out this way or this way, perpendicular to a contour. Right, so let's have a look at that. So the gradient vector here, differentiating this f with respect to x partially, we've got y. differentiating f with respect to y partially, we have x. Now grad g is equal to 2, 2. All right, so grad f equals lambda grad g is the equation y comma x, the vector, is equal to lambda times the vector 2, 2. So that gives us two scalar equations. Y is equal to 2 lambda and x is equal to 2 lambda. So now what we want to do is sub into constraint. So sub into the constraint here, and so we'll get 4 lambda plus 4 lambda is 1200. All right, so that's 8 lambda is 1200, which gives us lambda is equal to 1200 over 8, which is 150. Okay, now that we have lambda, sub that back into here, and so x is equal to 2 times 150, which is 300. So 2 lambda equals 300. Similarly, y is equal to 2 lambda, which is 300. Okay, so we got the same thing using Lagrange multipliers. So next, let's have a look at example 3.3. Find the maxima or minima of the function, this one, and we've already looked at that function, subject to this constraint x squared plus y squared equals 4. All right, so we've got f is 3x plus 3y all squared plus 2, and then our constraint g is x squared plus y squared minus 4. So grad f is, from before we had 18x plus 18y, comma 18x plus 18y. Now grad g is 2x comma 2y. Okay, so the equation grad f parallel to grad g gives us 18x plus 18y is equal to 2 lambda x, and then 18x plus 18y is equal to 2 lambda y. So we've got to solve this system. All right, now if lambda is equal to 0, then this side is 0, and we would have to have this side as 0, so then we would get y is equal to minus x. Right? That works in this equation too. Okay, so in this case, using the constraint, so the constraint x squared plus y squared equal to 4 gives x squared plus minus x squared equals 4. So that's 2x squared equals 4, or x squared equals 2. So x is equal to plus or minus root 2. And since y is the negative of that, y would be equal to minus or plus root 2. Okay, now if lambda is not equal to 0, then, well, these two are equal, right? So that what we would have is 2 lambda outside of x minus y equal to 0. So y would be equal to x because we could multiply by the inverse of lambda if it's non-zero. And so in this case, the constraint gives us x squared plus x squared is 4. So again, x is plus or minus root 2, and y, being the same, is also plus or minus root 2. Okay, so now that we have 4 candidates, now they're there, 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 and there. So now what we do is we just evaluate those points in the function to see which ones are bigger. So f of root 2 minus root 2 is, now subbing that into here, we've got 0 inside the square, so 0 plus 2 is 2. And that's equal to f of minus root 2 comma root 2. Okay, so in that case we get 2, and that's our minima. We already know this from the previous example, that our minima occurred along the line y equals minus x. Okay, so we already knew that. So now we're getting this via Lagrange. So next, let's take f of root 2 comma root 2. And so this time, subbing these into f, we have 3 root 2 plus 3 root 2 is 6 root 2. Squaring that gives 36 times 2 is 72, plus 2 is 74. And so this is greater than 2, so plus or minus root 2 plus or minus root 2, because it works for the minus as well, because those get squared, give maxima, and these give minima. Okay.